We're nearly there. Question 5. Right. Gosh. Ooh, electricity. Oh, that's a nice looking circuit. Let's have a look at this circuit. We've got some batch cells, or battery. 0.6 amps come down here, 0.4 amps going through this resistor. We're measuring the current here. Oh, the current splits up and goes down here. So I'm going to write that in straight away because I know 6, that must be 0.20 amps, right? Because that and that, I've got to add up to that, okay? Can't destroy current, it's a flow of electrons. Electrons, right. Resistance, R has a resistance of 11 ohms. Calculate the potential difference across it. Potential difference is just voltage, okay? So we know that PD, or volts, voltage, is equal to the current times by the resistance. Is that easy peasy? Always write the formula, remember. The current is 0.40 because that's what's going through here. The resistance is 11. We multiply those together. Oh gosh, I haven't got my calculator. Oh. Pretend I'm looking at my calculator. There we go. Let's have a look at the mark scheme, and they say that the answer should be 4.4. 4.4 volts. Write it in there. 4.4 volts. Okay. Once again, a mark for that. A mark for that. If you mess up the calculation because you haven't got your calculator working right, you will still get a mark if you do this bit, right? Always do formula, put the numbers in, and then do the answer. Yes? Yes? You say yes now, but right, will you do it in the exam? No. Right, okay. Oh, use the information from the diagram to calculate the current in S. This is why we always have our paper like this in the exam for real life. We've already done that. The current in S is this 0.2 amps. Okay, so the current is 0.20 amps. Oh, you can see it now. Right. Now then, if you want to really show off and show that you know what you're doing, you just say that 0.6, take away the 0.4 equals, okay? It's 1 mark, right? 1 mark, there we go. Bang. Complete the sentence by putting across, I was going to say kiss then, because little kisses, aren't they? In the box next to your answer, the student wants to measure the battery voltage with a voltmeter. Okay, that's what you use a voltmeter for. The voltmeter should be placed in... Okay, if this was the circuit, we always place a voltmeter in parallel. In parallel. What's the word? Parallel. Always voltmeters in parallel and ammeters in series. Okay? Easy peasy. Explain why the temperature of a resistor increases when the current passes through it. The current is the flow of electrons. Remember that, yes? The electrons are going through. Here we go. Here's a wire. We've got lots of metal ions, metal atoms in there, and the electrons are trying to force their way through. Okay? They bump into the atoms, the ions, and they start to vibrate and make heat. So, how can we put that into an answer? Electrons, key word, collide with the lattice. The lattice, remember the lattice? Because in a metal we talk about a lattice of ions, yes? Bit of chemistry, right? And then the electrons whizzing through. So the lattice, we could say the lattice, we could say the atoms. Lattice is the nice word, okay? Not lettuce, lattice. Alright. Okay, moving on. Oh my gosh, it's a 6-mark question. Okay, now then, here's a tip. Forget everything. Oh gosh, the lights have gone out. Forget everything that you have learnt in English just for this, because we don't want flowery language full of, I don't know, complex pronouns or whatever you do in English. We want some clear statements about science, right? So, a resistor is a circuit component. Read that while I turn the lights on. Okay, right, we're still there. Good. Okay, so I'm sure you've read that. Explain two and three LDRs and thermistors. First of all, let's do some bit of notes on a thermistor. Here's a thermistor. If we had, let's have a think, a temperature on the bottom scale and we had a resistance on this scale, a thermistor does this. Make it hot, the resistance drops. The reason being is that the electrons in a thermistor are pretty much bonded to their atoms, but if you heat them up a little bit they get a bit more energy and they can actually flow through the material. Okay. Now then, let's have a look at a light dependent resistor. Okay, we will have a resistance and we will have the light intensity here. It will do this. Okay, more light. Oh no, ignore that, I'm going nuts, right? A more light, less resistance, okay? Because the light, oh gosh, I'm being a numpty now. More light, less resistance, okay? The light helps to energize the electrons, just like in the thermistor, and so the resistance drops, okay? Right, now then, let's do this. Let's start with an LDR. Let's say that resistance changes with light intensity. Let's say that resistance is large when it is dark, not a lot of light. Okay, so in bright light the resistance is low, therefore the current that can flow through it, because it's a low resistance, the current is large. Okay, something like that. Okay, if it's dark, high resistance, I didn't mention that, did you? Resistance is large when it's dark. I should have added there really that the current flow is small. Okay, and in the bright light the current flow is large. Okay, do I need to say anything else? No, I don't. Bang. It's a really easy one, this. Okay, the thermistor. The thermistor. What can we say? Once again, R changes with temperature. And we could say as T increases, the resistance decreases, therefore the current increases. Okay, this is basically what they're trying to get you to say in this question. Hang on a second, this is to blow my nose again. Sorry about this, folks. Right, okay, here we go. Yeah, so basically in this question they're just trying to get you to regurgitate a bit of knowledge related to current. Mark's scheme says that in a 5 to 6 answer, you can read this yourself, a detailed explanation including the qualitative relationships. It's all qualitative, there's no numbers in this. It's fairly easy 6 marker. Blah, 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 blah. You could talk about the resistor cooling down, so the current flow will then change. The clear thing is just to get some clear bullet points, some clear sentences in here. We're not in English, we don't want flowery language, we want keywords. Keywords being resistance, current, light intensity, temperature, you actually write that out in a real exam, and so on. Okay, I've had enough of that question now. Bye bye.